Mercury, the smallest and least explored planet in our solar system. Its origin has intrigued scientists for years.
So this is the moment these probes, known as BepiColombo, set off. This is the early hours of this morning. They will be on a 7-year quest to discover more about what's known as the Swift planet.
It's the first European mission of its kind, and now we're joined by Tamila Masil from the National Space Centre. Good morning.
Good morning.
Did you watch it?
I did, yes. I woke up for the sort of 10 minutes, 2:45 this morning.
So there are two, aren't there?
Sure. Yes.
Two, 7-year journey.
Yes, absolutely.
Why is it exciting?
Mercury, I think for a long time we thought it was a fairly boring, rocky, cratered world, not interesting because there couldn't be any life there. And then NASA sent a mission a couple years ago called Messenger. And Messenger got up close and orbited it and actually opened up more mysteries than it solved. It found ice on the poles, and yet this is a planet that reaches 400 degrees Celsius, so it's an extreme. It found that the planet had actually shrunk. It looks wrinkled. Maybe it was bigger in the past. There's a lot of weird things about Mercury.
What would make it shrink?
Well, we don't know. We think that Mercury had maybe a bigger outer core, a bigger rocky layer, and as it was cooling, instead of the tectonic plates that we have here on Earth with different plates, it's all one thing, and it kind of shrunk, almost like a balloon would shrink and go wrinkled. And we see these features that are kilometers high, hundreds of kilometers long, and they're literally ridges called wrinkle ridges. And this is bizarre for us. We don't see this on other planets. And it's telling us how the early solar system formed, what happened, maybe where Mercury came from. So
now, you mentioned that curious fact that it survives at these extraordinary temperatures, but there are ice caps there. Is there an can you give us what's the best explanation for that thus far?
So Mercury doesn't have an atmosphere, which means it doesn't keep any of the heat. If it's facing the sun, it gets hot. It gets up to 450 degrees Celsius. That's kind of a pizza oven. Away from the sun, if it's in shadow, it can go down to minus 180 degrees Celsius. And there are craters at the top where they never get any sunlight. They're constantly dark. And so ice can form there and stay there. We don't know where the water came from. That's really interesting.
Can I ask a really stupid question? I'm sure. How can a planet not have an atmosphere?
So
what makes an atmosphere then?
An atmosphere, you need some gas. You need enough gravity to hold that gas around rather than it just kind of floating off, disappearing. And crucially, you need a magnetic field. The magnetic field actually protects it, kind of like a bubble. Mercury has a magnetic field. It's very weak. And actually being so close to the sun, it's blasted by a solar wind constantly. So it has some gases that come off. Doesn't really count as an atmosphere. But if a planet doesn't have a magnetic field, it's not going to have an atmosphere.
Now, in the lead-in, we said it a few times this morning, it's known as the Swift planet. Why is that?
Because it's closest to the sun, it's moving around quickly. Every 88 days,
so it's very literal. So it's literally
a fast-moving planet. It's the fastest-moving planet in the solar system. Because it's so fast to the sun, it gets a lot of speed just whipping around it.
And does that cause problems in relation to these craft?
Getting there.
Getting access?
One of the big challenges, and the reason it's going to take 7 years, is if you send something towards Mercury, you're also going towards the sun in the center of the solar system. The sun is massive, and it will speed up. It will be pulled in by the sun's gravity. And you need to slow down, because if you just go there direct, you'll have too much speed. You won't be able to go into orbit around Mercury. You'll fall into the sun eventually. So they have to slow down, and they're constantly braking. They're flying by other planets like Venus. They're coming back to Earth at one point just to slow itself down enough. And that's why it takes 7 years instead of a couple of months.
The instrumentation on these probes, these craft, there's quite a lot. There's more than has been before. So is this journey not just about Mercury? It's about the journey along there.
Well, you've got two different instruments. One's a Japanese one, one's a European one. And when they arrive at Mercury, they're going to separate. They're flying together at the moment. They're going to separate. One's going to be in a bigger orbit, and it's going to be looking at the magnetic field and the solar wind. So it's kind of studying what's happening from the sun in the bigger environment of Mercury. The European one's going to be closer in, and it's going to be looking at the surface. And one of the instruments looking at the surface is actually built at the University of Leicester. So National Space Centre, we're really proud of our colleagues there. It's a brand new type of X-ray telescope, And X-rays help us to understand what Mercury is made out of.
I'm
We will watch
fascinated.
with interest and see what they come back with. It's going to take a while,
Yeah.
but we'll find out eventually.
Yeah.
Thank you very much.
Thank you.
Tamala, thank you. Tamala Masil.